Welcome to this Wood Solutions presentation on fire and timber's density-related resistance to fire. Fire is a key mechanism of timber's natural breakdown. Wood burns at high temperatures. However, the wood also changes as its temperature rises high enough for it to burn. Between 100 and 200 degrees C, wood dries out and generates water vapour and other non-combustible gases. Between 200 and 300 degrees C, some wood components begin to undergo significant pyrolysis. Pyrolysis is a thermal decomposition of wood that occurs in the absence of oxygen, so that the wood starts to break down. From 300 to 450 degrees C, the wood breaks down further and vigorous production of flammable gases occurs. When these gases mix with air, in a temperature range about 400 to 500 degrees C, they can ignite and burn. Wood burns from the surfaces to the core. Once burning begins, charred wood is left behind. If burning continues, a layer of char builds up on the piece. Both this char layer and the underlying timber are efficient insulators, so high temperatures in the surrounding environment take time to transfer into the centre of the piece. As they do, these high temperatures start to degrade the underlying wood. A timber section under very high temperatures or flames will often have three distinct layers. The first layer is the char layer on the outside that insulates the wood underneath. The next is the zone of partially degraded wood under the char. This has already undergone pyrolysis to a greater or lesser degree. Lastly, there is normal wood underneath. This material is insulated by the char and the wood above, and it retains its structural integrity. If high temperatures continue, the charred wood burns away and the partially degraded zone moves further and further into the piece, and eventually the timber will be fully consumed. In the design of timber building elements, this burning behaviour is taken into account. Timber elements are sized accordingly, or they're protected from exposure to fire. The other factor taken into account in this design process is the density of the timber. The rate of thermal breakdown and burning is directly related to the density of the timber. The denser the timber, the slower it burns. So, in summary, very high temperatures can break down timber into flammable gases. This pyrolysis process occurs at elevated temperatures without oxygen. The products of pyrolysis mixed with air can ignite into flame at around 500 degrees C. Wood burns from the outside towards the centre. A layer of insulating char forms over a zone of partially degraded wood. This can slow the rate of burning. The rate of burning also varies with the density of the timber. The denser the timber, the slower that it burns. Unaffected wood retains its structural integrity.